All right, in this video, we are going to look at polynomial long division and synthetic division, and also that remainder theorem. Whether you're doing long division or synthetic division, remember that you need to use 0 for any missing terms. So we're going to start out with our long division process. We have 2x minus 5. We are trying to divide it into 4x cubed minus 2x squared minus 26x plus 18. Okay? So our process starts out by taking the first term in each one and dividing those. So I have 4x cubed. I'm dividing out a 2x. That leaves me 4 divided by 2 is 2, and x cubed dividing out an x would be x squared. That piece is the first part of my quotient, so it goes up on top. And then I need to take that 2x squared and multiply it back to my divisor. When I do that, I get 4x cubed minus 10x squared. And that's what I have to subtract off of this polynomial. So 4x cubed minus 10x squared. I am subtracting, and do be careful with that subtraction step. That's where most people make their mistakes. 4x cubes minus 4x cubes would be 0. Negative 2x squared, subtracting a negative 10x squared. Subtracting a negative is really adding. So I have a negative 2x squared. I'm adding 10x squared. That leaves me 8x squared. Then I bring down my next term, and I repeat that same process. So we are taking the first term divided by the first term. So 8x squared dividing out a 2x leaves me a 4x. That again is part of my quotient. It's going to go up on the top. And then I need to figure out what is 4x times my divisor, 2x minus 5. That gets me 8x squared minus 20x. So I'm going to write that under here. And again, I am subtracting there. 8x squared minus 8x squared is 0. I had a negative 26x. I'm subtracting a negative 20, so I'm really adding 20 x's. That leaves me negative 6 x's. Then I bring down my last term of 18. And one more time, I'm going to go through that process. So first term divided by first term. I end up with a negative 3. Goes on top as part of my quotient, and then I take negative 3 times 2x minus 5, which gives me negative 6x plus 15. And I'm going to put that under here. And I need to now subtract. So again, that first column should always drop out. Negative 6x, subtracting a negative 6x would be 0. 18 subtracting 15 gets me a 3. And so my final answer is the quotient on top. So this is my quotient. And this is my remainder. So final answer would be 2x squared plus 4x minus 3 plus that little remainder, which was a 3. I'm trying to divide it by a 2x minus 5. It's just too small, so I leave it as a fraction like that. All right, let's try one more long division problem. We have 3x plus 1 that we are trying to divide out of 3x cubed minus 5x squared plus 10x minus 3. So once again, I'm going to do first term divided by first term. If I take 3x cubed and divide by 3x, I'm left with an x squared. That's the first part of my quotient. Then I have to take that x squared, times it back to my divisor, 3x plus 1, which gets me 3x cubed plus an x squared. And I'm going to write that under here, 3x cubed plus an x squared. Then I subtract. The x cubes disappear. I have a negative 5x squared, and I'm subtracting another x squared. That leaves me negative 6x squareds. And I bring down my next term. And I keep repeating that process. Negative 6x squared, if I divide by 3x, is negative 2x. That goes on top. I take the negative 2x times my divisor again. So I have negative 6x squared minus 2x. And I put that underneath here. And then I subtract. My x squareds drop out again. I have 10x minus a negative, so plus 2x, which gets me 12x. And then I bring down my negative 3. And one more time, I'm taking the first term, 12x, dividing by the 3x to get a 4. 4 times 3x plus 1 would be 12x plus 4. And then I subtract. The x's drop out. I have negative 3 minus 4, which would be negative 7. So again, I have the quotient on top, x squared minus 2x plus 4, plus I have this remainder of negative 7, and I'm dividing it by 3x plus 1. All right, shifting to synthetic division. It says, remember, if you are dividing by x minus 5, you just use a 5 in front as your divisor. If you're dividing by x plus 3, you would use a negative 3 as the divisor. Also remember to watch for missing terms again. So when I look at my first example here, this is a linear expression, degree 1, so I can do the synthetic process. If I'm trying to divide by x minus 4, I am going to use a 4 in front for my synthetic division. I don't have any missing terms on this one, so I'm simply writing my coefficients. I have a 2, a negative 7, another negative 7, and then a 13. Okay? I'm going to divide out that 4. I start by bringing down the first 2, and then I multiply the 4 times the 2. That gets me 8. I write it up there, and then I add my columns down. We continue that process. 4 times the 1 is 4. Adding my columns, I have a negative 3. 4 times the negative 3 gets me negative 12. Adding gets me a 1. Now, when we look at our synthetic process here, what we have in our bottom column, our bottom row, the last number is your remainder, and then work backwards. Your next number would be your constant. The next would be your x, the next would be your x squared, and you'd keep going. So, final answer, I have 2x squareds plus 1x minus a constant 3, plus I have a remainder of 1, and I was dividing by x minus 4. Okay? All right, let's try one more of those. I'm dividing by an x plus 2. That means I have to change the sign and put a negative 2 out front. Now in this one, the polynomial does have some missing terms. I have an x to the 4th. I am missing some x cubes inside there, and I'm also missing some x's in between the x squared and the constant. So when I list my coefficients, I need a 1 for the x to the 4th. I need a 0 because I have no cubes. I have a negative 3 for the x squareds. I have no x's and a constant of negative 10. All right, again, that process, we bring down the 1, we multiply these, so negative 2, and then we add our columns down, which gets us a negative 2. Multiplying negative 2 times negative 2 is positive 4. Adding gets me a 1. Continue that, negative 2, adding is negative 2. Negative 2 times negative 2 is 4. Adding, we get negative 6. So again, our last term here is our remainder. Our next one would be a constant, x, x squared, and x cubed. So my final answer, I have 1x cubed, negative 2x squareds, plus 1x, minus a 2, plus a remainder of negative 6, and I was dividing that by x plus 2. All right, so that's long division and synthetic division. Our last topic is to look at that remainder theorem, which says if you divide a polynomial p of x that has degree 1 or higher by a linear expression, x minus a, then the remainder is equal to p of a. In other words, p of a is going to be the remainder when I do my synthetic process and divide out an a. All right? So our first example, we have the polynomial negative x cubed minus 3x squared plus 2x minus 5. There are no missing terms on that one. It says to find the value for p at negative 3. So I'm going to go ahead and put negative 3 out front. My coefficients are negative 1, negative 3, 2, and negative 5. Doing our synthetic process, we bring down the negative 1, we multiply. So negative 3 times negative 1 here gets us a positive 3. When we add, we have 0. Negative 3 times 0 is 0. Adding is 2. Negative 3 times 2 is negative 6. Adding is negative 11. That tells me that the value of the polynomial when I dump a negative 3 in for all my x's will be the negative 11. I am just looking for the remainder piece. All right, one more example of those. This time we are evaluating for a 4. Same coefficients on top, negative 1, negative 3, 2, and negative 5. We bring down the negative 1, multiplying gets me negative 4. Adding that column, I have a negative 7. Multiplying is negative 28. Adding that column is negative 26. And 4 times negative 26 is negative 104. Adding, I get negative 109. So the value of the polynomial when x is 4 is negative 109. Again, I just want that remainder piece.